Let's go over the next question. What does the path of an object look like when it is in uniform motion? So we know that an object is said to be in uniform motion when it covers an equal distance for every unit of time. That's when the object is in uniform motion. So how would the distance time graph look like for such an object, right? So if you take this, the distance, and this is time, and let's take a time after 1 unit, and 2 units, and 3 units, right? So we know that in 1 unit, let's say if it covers certain distance, say yes, right? If this is the distance that it covers in 1 unit of time, and we know that in 2 units of time, it should cover the same distance, right? It should be somewhere here, which should be 2s here. And after 3 units, it should cover somewhere here, which should be 3s, right? So that is how the graph can be plotted. And if you really connect all these dots, it would be a straight line, right? So it's going to be a straight line. What does the path of an object look like? The path will be a straight line, but when for an object that is in uniform motion. Let's go to the next question. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 times 10 power 8 meters per second. So let's use this. Let's use the space for our calculation. So this one says that, let's assume this is the ground station, right? And there is a spaceship here. So this is your spaceship. Right. So what this says is that during an experiment, the signal that traveled from the spaceship till here, right? So let's take this as a distance, yes. The idea is to calculate what is this value of this, but we know that the speed of this, the speed in which the signal traveled is 3 times 8. So the speed of the signal is equal to 3 times 10 power 8 meters per second. Right? And we understood that during an experiment, a signal from the spaceship reached the ground station in 5 minutes. So which means that it was able to cover this distance. This particular distance was it was able to cover this distance in 5 minutes, right? So the total time taken, right? The total time was 5 minutes, which means 5 times 5 minutes has how many seconds, right? 5 times 60, right? Yeah, 5 times 60. So this is your these are the total. This is the time it took, which is this is the time the signal took to reach the ground station, which is 5 times 60 seconds. Sorry, there is a lag here, so it is going to be it is going to be 5 times 60 seconds. So we know that this is the speed of the signal is 3 times 10 power 8, and the time taken for the signal to recover this distance of s is going to be 5 times 60, which means that you can if you equate the speed of speed with distance, it's going to be 3 times 10 power 8 is going to be equal to the distance traveled over the time taken, 5 times 60. Right? So your distance s is equal to 3 times 10 power 8 into 5 into 60. So this is going to be the value. This is going to be the distance traveled by the signal from the spaceship to the ground station. So let's move on to the next question. When will you say that a body is in uniform acceleration, and when will you say that a body is in non-uniform acceleration? Okay. So we say that a body is in uniform acceleration when it acquires an equal velocity for every unit in time, right? So when it when we say that a body accelerates, if its velocity increases at a constant rate, right? So if you really plot this, if you plot this behavior on a velocity time graph, say for a body that goes in a uniform acceleration, if this is velocity and this is time, we know that a body that undergoes uniform acceleration will always, its velocity will always increase by a certain number, certain constant number, right? So it will be a straight line. So your it's going to be a straight. The path will be a straight line on a velocity time graph. However, a body that is not in a uniform path will not be a straight line, right? Because it will acquire the change in velocity will not be the same for every unit increase in time, right? So the body might have at time 1, the body might have a velocity of it might have a certain velocity, but at time 2, it might drop, or it might slow down. If it slows down, then your velocity would slightly decrease. And let's say in at time 3, let's say if it picks up once again, so maybe it is here, right? So the path is not going to be a straight line for an object that is that is not, whose acceleration is not uniform. Right? So that's the difference here. Let's go over the next question. A bus decreases its speed from 80 kmph kilometers per hour to 60 kilometers per hour in 5 seconds. What is the acceleration of the bus? Okay. So here we say that the bus was traveling at an initial velocity of 80 kilometers per hour. So let's take U is 80 kilometers per hour, and it reached a velocity of, or it reached a speed of 60 kilometers per hour. So let's take the final velocity or speed is going to be 60 kilometers per hour. And it was able to, its speed actually decreased. So the speed decreased from 80 to 60 in 5 seconds. Right. So time is equal to 5 seconds. So in a sense, let's convert these into meters. So you can be written as 80 into 1000 meters divided by 1 hour has 3600 seconds. So it is basically, you can write the same thing as 80 kilometers per hour can be written as 8 into 1000 by 3600 meters per second. Similarly, you can write this one as, you can write V as is equal to 60. Sorry, this has to be 80, right? So it has to be 60 into 1000 over 3600 meters per second, right? So and T is equal to 5 seconds here. So we learned that the formula, one of the equations of motion, through one of the equations of motion, we learned that V is equal to U plus AT, which means that 80 times 80 into 1000 over 3600 is equal to 60 into 1000 over 3600 plus A is what we need to find, and the t is going to be 5 seconds, so it is 5a. So if you rearrange this equation, if you bring this out here, so it becomes 20 into 1000 over 3600 equals to 5a. So if I'm going to take these off, right, so it is going to be 200 over 36 into 5, which is equal to a, right, and this is going to be 40 over 36. 40 over 36 is, yeah, so it's going to be 40 over 36 is 10 over 9, right? So it's basically 10 over 9 is your acceleration. 10 over 9 meters per second squared is the actual acceleration. Right? Okay. Oh, I think I made a slight mistake here. So you know what? This one has to be. This one has to be. This is not V, right? So this is not V, but rather this has to be. V is actually 60, right? So let's redo this whole thing. So your V is going to be. Your V is actually 60 into 1000 over 3600, and the U is going to be 80 into 1000 over 3600 plus 5a. Right? So now when you bring this out, this becomes minus 20 into 1000 over 3600, which is equal to 5a. So your a is going to be equal to minus of 20 into 1000 over 3600, right, into 5. So if you take these off, it's going to be minus 10 over 9 meters per second. Yes, I was missing this minus here. So because it was the speed has come down, which means that the acceleration has been negative. So the right value is minus 10 over 9 meters per second. Let's go to the next one. A train starting from a railway station and moving with uniform acceleration attains a speed 40 kilometers per hour in 10 meters. Find its acceleration. Starting. Okay. So we say that the train is actually starting from a railway station, which means that it's very similar to how we just solved. So let's move this whole thing here. So let's try to solve this part. Okay. So let's try to solve this part. So in this case, the train is starting from the station, so which means that u is equal to 0, right? And u is, let's take it as, let's do everything in meters per second. So u is 0 meters per second, and the train it reached a speed of 40 kilometers per hour, right? So v is equal to 40 km per hour, and which is equal to 40 into 1000 divided by 3600 meters per second. So this is your final speed or final velocity. Now it took 10 minutes to reach here. So which means that time t is equal to 10 minutes, which is equal to 10 into 60 seconds. Right. So now let's apply the same formula here, right? So we know that v is equal to u plus at, and which means that 40 into 1000 over 3600 is equal to 0, which is your u is 0, plus 10 into 60 times a, right? So this is what is your acceleration. So a is equal to 40 into 1000 divided by 3600 into 60 into 10. So let's cancel these zeros out. Let's cancel this one as well, and let's cancel this 0 as well. So which means that its acceleration is 4 over 36 into 6, which is equal to 1 over 54. Right? So it's going to be 1 over 54 meters per second. So that's your acceleration here. The train accelerated at 1 over 54 meters per second square. Right. Okay. Got it. So let's move to the next one. So what is the nature of distance time graph for uniform and non-uniform motion? So we just learned that for when something is in uniform motion, for a distance time graph, we learned that let's just call the distance as d here. The distance and your time is here. So when something is in uniform motion, we know that it covers the equal distance at every unit of time. So which means that it will be a straight line, right? The distance time graph will be a straight line, something like this. But whereas when the speed is not uniform, which means that the object is undergoing an acceleration. So in that case, your speed is going, your same distance time graph for that object will look slightly different in a way that for every unit time it will cover higher distance, or the distance covered will not be the same, will not be equal for every unit of time. So if it is accelerating, it means that after between 1 and 2 units of time it will cover more distance, and between 2 and 3 it will cover even more distance. So it means that your object, so your path is going to be curved here. So this will be a straight line for uniform motion, and this will be a curve for non-uniform motion. The path is going to be a curve on a distance time graph. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? What can you say about the motion of an object whose distance time graph is a straight line? Right? Okay. So what this means is you're saying that this on a distance time graph. Let me use a different color. So this is your distance. This is your time, which means that what we're saying here is it's a straight line, right? The distance time graph is a straight line like this, which means that the object at time t has covered a certain distance. Let's call it x, right? It covered at time t. At time 1, it was able to cover x. At time 2, it was able to cover the same distance x. Basically, it has not increased, and it doesn't increase. It's not covering additional distance as the time elapses. So, which means that the object is actually stationed at a point. The object is at rest, right? So when the distance time graph is a straight line that is parallel to the x-axis or the time axis, which means that the object is actually at rest. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? So let's try to plot that out. So now we are talking about speed time graph, right? So if the speed time or the velocity time when the velocity time graph is like this, which means that what this means is that at every increase in time, at every unit increase in time, it is not the object is not acquiring additional velocity, which means that the velocity or the speed is actually constant at every point in time. So, which means that the object is not accelerating, right? So, it is not accelerating. On a velocity time graph, if the velocity time graph is parallel to the x-axis, it means that the object is not accelerating. It is not acquiring any additional velocity. The velocity is constant.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.